Hey, this is IoT Group 5. My name is Steyaert. My partner is Aditi Munshi, and our project is the Smart Gardener. So the problem we encounter is you might have a household plant at home that died because you didn't really have time to take care of it. Um, and so our solution is that we have a Smart Gardener that monitors your plant for you. It tells you the metrics on your phone for various time ranges, and it beeps when your plant needs to be watered or it's dying. You can also see photos of your plant on your phone. So a quick overview of the sensors. We have an accelerometer, light sensor, humidity sensor, thermometer, soil sensor, an LCD screen running on I2C, and we have LEDs and a buzzer on GPIOs of a Raspberry Pi microcontroller, and then we have a camera connected via USB also to the Raspberry Pi. So we take four different metrics of the plant, the lux, the temperature, the soil moisture, and the humidity, and each of those values is given a score from 0 to 25 based on how those values relate to what the plant needs, and they're added together to give an overall health score from 0 to 100. This health score is sent to the LCD screen. If the score is 70 to 100, the green LED lights up. If it's 40 to 70, the yellow LED lights up. And if it's 0 to 40, the red LED lights up. If the red LED lights up, a buzzer also goes off. The information is also sent to MongoDB via PyMongo, and the user can view the data on their phone, and the phone talks to MongoDB via HTTP requests. You can also see the status of your plant if it needs water or if it's fallen over. This was simply integrated using the accelerometer and the soil moisture sensor. Um, and so if your plant falls over, the red LED will light up and the buzzer will go off. And if the plant needs water, the blue LED will go and the buzzer will go off. And you can view this information on your phone. Next, I'm going to talk about the construction of the device.
So if we take this box apart, you can kind of see that the Pi and the other sensors go to this perf board right here, so here's the Pi, and here's the screen with the perf board. Off of the perf board is the connections to the sensor. You're gonna zoom in.
This is the sensor we constructed. You can see that the accelerometer, the light sensor, soil moisture sensor, and humidity and temperature sensor are all tightly soldered onto a perf board, and all the I2C connections are made in the middle. So here you can see the data on MongoDB over time of our plant. So for example, you can see here the overall health of the plant as a function of time. This is for 3 days that we took data. You're able to see the max, the min, and the mean score of the plant health over time because it took many data points and we can't show all those data points in one plot. You're also able to see the different values over all time. So this top row is over all time for each of our 4 parameters. This is over just today, so you're able to see the data over the day. So for example, you can kind of see how it got dark today, and this would be the beginning of the day where it was already light. And you're also able to see the values over just an hour. So here you can see humidity, light, soil, and temperature over just 1 hour of time.
So right now we're starting our demo. You can see that the health is at 70. The green LED is on because the health is 70, and the red LED is on and the buzzer is on because the sensor has fallen over. I'm gonna turn the buzzer off. Now if you come over here, you can see the data. It's being sent to MongoDB live. If you want, you can pause the video and you can look at these values. And now if we come over to here, I can start the app that we made for this. It's an Android app on this tablet. And so you can pause the video and zoom in. You can see that these values match the values that are being loaded on the Pi. And you can also see the health score over time on the tablet. So now on the app, we can go over to data. And this will load the data that you saw before from MongoDB. So this would be humidity. Down here you have humidity, light, soil, and temperature. And up here you can change the different time ranges of your data. So this would be humidity over the last day, Over here we can go to temperature, and we can look at temperature over all time, which is like 3 days. And so here's the temperature, and then you can go back. It's a little slow. And then these values auto update. You can also see that the blinker red LED is on, which means that the plant has fallen over. You can finish it. Another feature of the app is you can look at the images of your plant. So this will show you the most recent 10 images of the plant, and it takes pictures of the plant every 2 minutes. So you can sort of click around, and you can see the date changing at the top as I click around. So this will be a useful way to see how your plant is doing if you see that the values of it get too low.
For this project, we'd like to thank Dr. Jang and the TAs for their guidance and support, the EE department for donating a plant for us to use, Columbia University Formula Racing for letting us use some hardware, and John Kazana for letting us use the 1206 lab for extended periods of time.